Hey guys, welcome to your next advanced C++ and graphics tutorial. Today we are going to make a few changes to our engine that are going to make the challenge video much easier. It's going to give us a lot less code that we have to write for the actual game. I want to do the challenge episode in 2 more episodes, including this one. So the next episode we'll go over some basic movement stuff, maybe a little bit of like projectile stuff. And then we'll do the actual challenge episode, and hopefully you guys will know everything you need in order to make the simple game that we're going to make. So first, the first thing we should do is probably make the input manager. Now the reason we need an input manager is if I go ahead and run the game right now, whenever I use this little setup we have here to move the camera around, it doesn't really work exactly like we would want it to. When I press A, the camera's moving to the left, and that's what we want, but it's not moving to the left smoothly. It's like jerky, and it's only moving whenever an actual input is received from the keyboard. So depending on what kind of keyboard you have, it's going to go at a different speed, depending on your operating system, all that. That is not what we want at all, and it just doesn't work. So instead, what we should do is create an input manager class. And in this class, what we're going to be able to do is ask it whenever a key is pressed and when a key is not pressed. So as soon as we press the A key, that key pressed value is going to be true, and then we can make it smoothly move using that, instead of just moving whenever we have an input from the W key. So we're going to get rid of all this stuff, but first let's go ahead and make the class. Let's go over to Engine, and we're going to make a new class. So add class, and we will call this input manager. Just like that. Go ahead and finish. And here we are in our input manager class. Now this is going to be a pretty simple class for now. In the future we might expand the input manager to allow us to map keys to different functions so that you can actually change your key bindings and things like that. But for now it'll just be very, very simple. Let's make sure we wrap everything in our Vorb engine, or sorry, our Bingen. So namespace Bingen. Vorb is actually the name of the game engine for Sea of Andromeda that we are working on. Now you know, I haven't told anybody that. Well, anybody outside of the team, I believe. Alright, so all that is in namespace Bingen now, so it should be accessible once we include the header file. Now another thing we want to do is we want the ability to tell the input manager that we have pressed a key. So we're going to say void press key. It's probably a better name for that, but that's fine. And we are going to store the ID of the key as an integer. So we'll say, actually, it would better be an unsigned integer. I don't think there are any negative IDs. Let's actually see here if SDL uses a unsigned integer. And it's an enum, so it's probably all positive right now. So we're going to go ahead and do that. We're going to say unsigned int. And this will be key ID, and we're just going to use the SDL key IDs right now. A better thing to do would probably be to wrap all of the SDL keys in your own enum class or something like that that gives you the ability to pick the bindings yourself, and so that if you ever wanted to switch to a different input library, like instead of SDL, maybe GLFW or something like that, it would be really easy to make the change in your games, because all you would have to do is change the engine and the games wouldn't have to worry about it. Okay, so press key, key ID, and we don't want to define it here. We want to define it in the C++ file. So we'll put that right here. Go ahead and put our input manager : Let me zoom in. Some of y'all don't have good internet speeds, so you probably can't view this at full resolution. Let me zoom in. All right, and we also need void release key, key ID. All right, and we're going to need a bool is key pressed, unsigned int key ID. And that should be all we need as far as public goes for now, for our basic stuff. We'll probably want to do some mouse control in here too. We might not, it depends. All right, so private variables, what we're going to want to do is we're going to want to be able to store all of the states for our keys. Now we could store a really huge giant array of all of booleans that are mapped to these key IDs, so that whenever we press a key, we can set the boolean to 1. Whenever we release the key, we can set the boolean to 0, and then is key pressed will just return that boolean. But that would use a lot of memory that we probably don't use. We only need as much memory as we have keys being used in the game. So instead, I think we should use a map, and particularly an std unordered map. So let's go ahead and include unordered map. And an unordered map, I sort of went over it in our little maps tutorial video. But an unordered map behaves pretty much the same way as a normal map, except internally it's stored as a hash table instead of a tree. And this actually makes it slightly faster to access because it accesses in constant time instead of logarithmic time. However, it can use up a little bit more space than a map. And since it's called unordered map, that's because it doesn't actually store things in order like the normal maps does. So if you wanted to have everything stored in order, you wouldn't use an unordered map. But for our cases, we do not need everything to be in order, so we're fine. So we're going to store the unordered map where the key is going to be an unsigned int, and the value is going to be a Boolean, which is just going to be like, is it pressed? So this will be key map. Like that. And if you're curious, unordered map is built on top of a hash table. I believe I told you that, so you can Google what that means. I'm not going to teach you how a hash table works. All right, so when we press a key, all we need to do is say key map, and we could say keymap.insert to set it, but there's also a little trick you can do with maps, unordered maps and normal maps, is you can just treat them like an array, and we can say keymap key ID equals true. Now what this is going to do is it's going to first check if this key ID is even in the map. If it's not in the map, it's going to go ahead and create it, and then it's going to set it to true, just like that. It's really simple. So let's go ahead and grab these next two functions and put them here, do all the normal stuff we need to do. There we go, all right. Press key, release key is key pressed. So release key is just going to set this to false. Super, super easy. And finally, is key pressed is just going to return the Boolean associated with this. Now we could say return this. However, this is not good because if nobody has ever pressed or released key ID, then this isn't going to exist in the map yet. And whenever we call this key map key ID right here, this is what's called treating it as an associative array, by the way. What this is going to do is it's going to create a default variable there for it. It's going to go ahead and create a value for the key ID and then a random Boolean. It could be true or false. We're not going to know which one it is. So we don't want to do it this way. Instead, what we want to do is check manually and see if it's in the map. And if it's not in the map, we don't want to insert it. We just want to return false. So we'll do it the usual way. Auto it equals, and remember auto is the keyword that automatically picks the type. It's going to be key map. Auto it equals keymap.find, and we're going to look for key ID. And then we just have to check and see if it found it. And to do that, we say if it is not equal to keymap.end. So if it's not equal to keymap.end, that means it did find it. So we're just going to return it arrow second. Otherwise, it didn't find it. So let's just return false. It's not pressed. We'll just return that by default. And that is pretty much it. It's a very, very simple input manager right now. We might add some mouse control stuff. Let's just see how important that is with our game. So now what we can do is instead of doing all of this stuff, what we can do is give ourselves an input manager. So let's go into main.game.h and do that. That's down here, main.game.h. Let's include Benjin input manager. And let's go ahead and make one down here somewhere. So we'll say Benjin input manager. And then in main.game.cpp, all we're going to do here is whenever we have an SDL key down, instead of doing this huge switch statement for it, we're just going to do this. We're going to say input manager dot press key, and we're going to press event.key.keysim.sim. And that's the unsigned int that we are going to pass into input manager, and it will then record that as a key press. So we also need to check for key up. We didn't before, but now we actually do need to make sure that whenever they release the key, that we set that value, that Boolean, to false for the key. So we're going to say case SDL key up. And we do the same thing. We say InputManager dot release key event.key.keysim.sim. So long. All right. And then break. So now we can take all of this stuff and we can move it somewhere else. So let's grab it all out of here. Let's delete that. Now our process input function is much simpler. So what we should do is somewhere we should actually process this. Let's go ahead and do it in the process input function. That's fine since we are still processing input here. So what we're going to do here is instead of checking in here whenever we're getting the signals, we're going to just check if they are pressed. We're just going to check our input manager. So we're going to say if input manager dot is key pressed, and we're going to say is key pressed SDL key W. Then we will call this. And we do the same thing for everything else. So let's just copy this. This will be S here. This will be A. This will be D. This will be Q. I'm probably doing this in the most horrible way possible. And this could be E. Now we need to put all of the end curly braces on. Can't forget those. This is so nasty, but we're almost there. And then we need to remove all these breaks. I am the king of copy paste. Don't ever forget that. And tab it over with Shift Tab until it's lined up. And there we go. Here is our new process input function. And now it's probably going to process a lot faster. Oh, I forgot parentheses all the way down here. Now it's probably going to process a lot faster than it was before because instead of just moving whenever we receive an event, we're going to be moving continuously as long as the key is pressed. So I'm going to go ahead and anticipate that and reduce camera speed by a factor of 10, and let's see if that is slow enough. I don't think it's going to be slow enough. Oh, it is slow enough. Okay. We're only getting 20 FPS, that's why. So now when I press WSAD, it is much more reasonable. When I zoom in, it's reasonable, it makes sense. It's not all jerky. It's a little jerky because we're rendering 2000 sprites, I think. Let's change that. Where are we rendering everything? Here we go. Yeah, we don't want to render 2000 of them. Not until we have optimized more. If you're curious about what the first optimization will be, it's to get rid of all the new and delete calls in Sprite Batch, because calling new and calling delete slows down your program. The heap allocation isn't very fast. We will fix that in the future, though. We don't quite need it for the first game, I don't think. All right, let's try it again. It'll probably be a little faster. Let's see what it looks like. There we go. It's a little bit faster. We have smooth movement. It's a little jerky simply because of the frame rate, I believe, and because of the video recording software. But it is updating every frame. It's moving every frame. And it's very responsive. It immediately moves whenever I press the key. Now, I don't believe we've implemented variable time step yet, but we will probably be doing that in the next video along with going over some vector stuff. Before we end this video, though, let's do another small thing that will help us out for our game challenge video, and that is to take this frame rate limiting stuff and FPS calculating stuff and move it into a class that will do it for us. There's no sense in us having to write this entire function every time we want to make a game. So let's go ahead and make something in Bingen for that. And what I think we should do is we should have several classes for different timing things. So we could have like a timer, we could have things for limiting the FPS, we can have all sorts of things. We can have high resolution, low resolution timers. For now, we'll just worry about the FPS, and we don't want to add a class. Let's actually just add a header file manually. We're going to add a new item. It'll be a header, and let's call it Timing.h. So it'll hold all our timing classes and functions, and then let's make a Timing.cpp. New item, Timing.cpp. All right. So let's create our first class in timing. First, let's go ahead and create our namespace. So namespace Bingen. I'm a little out of it today. I'm on new medication. Sorry, guys. No, that's not an excuse. Let's copy that into CPP. Zoom in. All right, so here's our namespace engine. And the first class we should make, let's call it class, let's call it FPS Limiter. FPS Limiter. Like that. I like it that way. And tab it over. All right, so the FPS Limiter class. Well, it's going to need an init function. So we'll say, let's go ahead and give it a constructor that does nothing since it's a class, FPS Limiter. And we'll put that in the CPP file. But first, let's go ahead and do the init function. Don't forget public, so we can access this stuff. FPS Limiter, let's do void init. And let's do some functions. So what do we need this class to do? If we go to main game and we go to the game loop, the things we are having it do are we are going to have it grab this start ticks variable. We're going to go ahead and have it calculate FPS, and we'll make it so that we can print out the FPS with it. And we're going to limit the FPS. So there's three things it's going to do. The calculate FPS, that can happen at the same time as this part right here. They can happen in the same function call. And this start thing, the start ticks equals STL get ticks, this can happen in a single function call. So we really only need two function calls from this game loop. And I think we should say FPS limiter.begin and FPS limiter.end. I believe that is, or FPS limiter dot end, I guess, works, and that will handle it. I believe that should work. All right, so we'll say void begin, and then let's say int end, and end will return the FPS. Okay, so let's put a comment there. End will return the current FPS, and let's return it as a float, because you can have a floating point FPS. And so init, begin, end. All right, so there's going to need to be some private variables. I'm not sure exactly what they all are yet, so let's just copy this for now into namespace engine. Actually, we need all of these. And let's grab this and put that : before everything. There we go. Don't forget to include Timing.h. And also, don't forget a pragma once. This will prevent circular includes. Alternatively, you could use include guards. Google those if you don't know what they are. All right, and finally we need curly braces for everything. I'm just going to copy that, paste, 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 and this is in the header, so that's fine. All right. Oops. What did I do? Look at me. What am I doing? Wasting time. Okay, now we're good. All right, so the constructor, for now we'll do nothing. It may come in handy later. The init function. I believe what we should do with the init function is set a target FPS. Let's also make a new function, void set target FPS. Target FPS. And let's go ahead and have that as a private variable. Target FPS. So init function will also take the target FPS, and it will call set target FPS. So let's go ahead and take this, put it in here. FPS limiter : set target FPS, and put float target FPS in the init function here. And so the init is just going to call set target FPS like that. It might also do some other things. If it doesn't do anything else, then there's probably no point in having it, and we can go ahead and delete it. Now the begin function, this is what's going to get that initial SDL ticks. So what we want to do is we want to go ahead and, since we're using SDL in this engine, we're going to go ahead and use SDL some more to get the ticks. So let's go ahead and here we're going to say include SDL, SDL.h. And let's go ahead and have a start ticks variable. Wow, I didn't even give it a type. GLUint start ticks, and let's just say, so we don't have to include OpenGL, let's go ahead and just say unsigned int. Remember, unsigned int is pretty much the same as a GLUint, except unsigned int is not guaranteed to be 4 bytes, but there are ways we can fix this, and we will create our own types in the future that can guarantee that. What am I doing? Unsigned int start ticks. Okay, that should do for now. So we're going to go ahead and whenever we call begin, we're going to say start ticks equals SDL get ticks. There we go. And so now we can, let's go ahead and start adding this to our main function so we can see how it works alongside it. Let's go ahead and include the file, Timing.h, and let's make ourselves an FPS limiter. So as you can see here, as we keep adding more functionality to our engine, our actual game becomes much more simple because all we have to do is combine a bunch of these classes from Bingen and they will do everything we want. If we want a camera, we just get a camera. If we want a sprite batch, we just get a sprite batch. It's really, really great. This is how you should design your games and your engines, is so that your engine does all the heavy lifting and your game just does all the game related stuff. All right, so here we are. This is the start ticks. So let's go ahead and in init systems, we'll call FPS limiter.init, and we'll say target FPS equals target FPS. I thought we had a target FPS. Max FPS. That works. Max FPS. Maybe that is a better name for it. Let's go ahead and change that to max FPS. That is a more indicative name, I believe. Set max FPS. This should be max FPS. Copy that, copy that. Max FPS, max FPS, max FPS, and set max FPS. There we go. All right, back to main game. Let's go ahead and finish this up. So FPS limiter.init. There we go. Right here, this is where we normally would call SDL get ticks. Instead, we're going to just tell the FPS limiter to begin. This is the beginning of a frame. In fact, begin frame might be a better name for this function. So let's go ahead and do that. Let's say, well, begin is fine. Begin is fine. Begin frame would be cooler, I think, but this works as well. All right, process input, camera update, draw game, calculate FPS. So this calculate FPS and pretty much all of this stuff right here, it's going to happen inside our timer, inside the end call. So let's go ahead and move the calculate FPS function there. So we're going to go ahead and make that, and we'll make it a private function. So void calculate FPS, and we'll put that in timings.cpp. I'm just going to go ahead and let it indent from now on, I guess. Just keeps doing it. It's only one indentation, so oops, it's not that bad. I'm so inconsistent. I'm so bad. Just do whatever you want. It doesn't matter. FPS limiter : calculate FPS. So let's go ahead and just steal our calculate FPS function from main game. Let's grab you. And I'm going to delete this from main game because we no longer need it there. Goodbye. Good riddance. Back to timings. Let's put it there. Now we're going to have a few variables that are probably missing. We're going to have frame time and FPS. So let's go ahead and steal those variables from max FPS, frame time. Let's grab all three of these and put them in timings.h. Paste them right there. All right, so that's cool. Let's go back to main game. What else do we need? Don't need calculate FPS there anymore. All right, so this is printing the counter every 10 frames. This is actually, we're still going to do this, I think. We're just going to use the return value from our FPS limiter.end to get the FPS, and then we're going to print that out. And actually, we should probably still store the FPS here. That would be useful to have. So let's go ahead and still store that. It's stored as a float FPS. No sense in getting rid of that. So what we're going to do is we're going to say here, we'll just go ahead and say FPS equals FPS limiter.end. And that will return the FPS for us. And it's a semicolon. Underscore FPS. And FPS limiter end is going to do this. It's going to limit the frame rate and it's going to also calculate the frame rate. So let's go to timings, and here's end. So at the end it will limit the frame rate, but first it will calculate the FPS here. And this should be underscore start ticks. All right, and that will delay everything, calculate the FPS. Awesome, and the FPS is stored in the FPS variable, so we're going to return FPS. Return FPS, looking good. Set max FPS equals max FPS. Looks like this function is pretty much done, or this class is pretty much done. So now we can go back to main game, and let's get rid of that. And so here's where we just want to move this. We'll put this below that, below the end function. And that will print out FPS once every 10 frames. We don't want FPS Limiter to do printing for us. It's not really a good practice, because we may want to display this in a different way. We want to display it with graphics. And once we have a font library, we will be able to display it with graphics. But right now we can't do that. It's a little bit complicated, and we're not going to have it in time for our little game. All right, let's run that and make sure it works. Make sure we get no compilation errors, and we do. What did I do wrong? Max FPS, undeclared identifier. Oh, right. I am no longer storing a max FPS. Let's not get rid of that. It's okay to have it in both places. And is there anything else? We're good. All right, so FPS Limiter still works. I am at a solid 30 FPS here. And my little guys are moving around however I want them to. Everything is great. Thanks for watching, guys. I will see you in the next tutorial where we're going to learn about moving sprites around some more and possibly do variable time step and particles and stuff. It may actually be a good idea to break it into 2 tutorials, but I really want to just have one more tutorial until the game challenge. So we'll see. I'll see you guys next time.